Let's put together everything we've learned about z-scores and how to make this work in one problem. Boy, these are fun. Okay, so we have a standard normal curve. Again, I didn't even have to really tell you. Once you see a z right there, you know this is a standard normal curve. Also, it has a center line at 0 and a standard deviation at 1, so it kind of makes it obvious. I've given you one area and one z-score, but your job is to find the missing areas and the missing z-score. So it's a little bit of a puzzle. And if you're wondering, like, well, how do I go about this? And the answer is for each one of these problems, it's different depending on what you're given. So you have to think to yourself, okay, if I know this area, could I find this z-score? Or vice versa, if I know this z-score, could I find this area? And the answer is you could do either one. They both would work. The one thing you cannot find first is this middle area. That's not going to be possible yet, but we'll get there. So how about we go in the same order that we went in the problems? We know a z-score, so let's think about this. We have a z-score. We want to find an area. So that's this one, step 1. Right? So that would be the one on the left. So we know the area, or excuse me, we know the z-score. We want the area. Okay, so number 1, which is like number 1 on the table. All right, so we know that z-score is negative 2.350. Okay, so let's go to StatCrunch. Oops. I moved off StatCrunch to upload a video for you guys, and there we have it. Okay, so I'm in my normal calculator. Again, let me just reiterate how you do that. So stat, calculators, normal. There it is. Okay, so I want it to be left, right? I want a left shading like this has, but I know that the z is negative 2.350. Enter. So if I do that, I can tell that that little area in the tail is 0.009. I think I only wanted 3 decimal places here. So let me write this out. So the probability that z is less than or equal to negative 2.350 equals 0.009. That's the answer, right? That's the part we circle. Right? This is your area. If I numbered them, let me just say that's area 1, right? So area 1 is 0.009. Lovely, beautiful. Okay, well, we can find the middle area now. We don't have to wait. So the middle area is really easy. It doesn't even involve StatCrunch. You know that the whole curve makes 1, right? So the middle area has to be 1, take away the other 2 tails, right? So let me write that. So number 2, actually I'm just going to say area equals. All right, if I take 1 and I take away the area on the left, which was 0.009, we just found that, and I also take away the area on the right, which was 0.115. Here, I'll give that like a green shading or something. There we go. So that was 0.115. So I'm going to take away 0.115. That'll get me, well, I don't know, but that's what Desmos is for. So let me go grab Desmos. Oops, I've clicked away from my Desmos somehow. I don't know how to manage that. So let me reopen it. Oh, I had it. It was right there. I was losing my brain. All right, 1 take away 0.009, take away 0.115. And then my middle would be 0.876 right there. Okay, so there's my middle, 0.876. So that's area 2. Let me just number these. So area 2 is 0.876. All right, so now all I need to do is find the z-score over on the right. Z number 2, if you will, because z number 1's over here. All right, so to find z number 2, we're going to use rule number 2 on our sheet because we have the area. We are looking to find the z-score. We want to find a z-score, right? Z is blank. We want to find it given an area, which was 0.115 right here. Okay, so let's think here. Well, let's follow what it says, and then we'll be able to write this out. So I want to find the z-score, so I'm going to go into StatCrunch. Let me make this smaller again. Let me get back over to StatCrunch. All right, so I want to make it standard, but I want it to go the other way. I want it to be a greater than. And I don't know what the z-score is, so I'm going to leave that blank. But I do know that the area was 0.115. It says right there. So that area is 0.115. So I put in 0.115 as the area right here, and then I click compute, and it tells me what the z-score must be. 1.200 if I'm only doing 3 decimal places. So let me write that out. So the probability that z is greater than or equal to, right, again, I'm copying, p parentheses z greater than or equal to 1.200 equals 0.115. And the answer is actually the 1.200. That's the answer. Just like it shows us on this chart, right? We circle this piece, right? This piece, the z-score is the answer. Right? So that z-score right there is 1.200. All right, I'm going to show that in a TI-84. If you're not using a TI-84, you can skip ahead to the next video. All right, TI-84s. Let me scooch this over. Oh, I can make this work. All right, so lovely. Okay, so for the first one, that's a normal CDF question. So second distribution, normal CDF, and you would tell it, so it's a left tail. See how this is the left tail? So you'd say negative 1E99 all the way up to negative 2.350. Paste, enter. You get the same answer as they did, 0.009. And again, for the middle part, that's easy. 1 take away 0.009, take away 0.115. There you have it, 0.876. And then for the other one, this one, well, that's a trickier proposition. If you have a new calculator, like I have here, I can say inverse norm. I can say the area is 0.115 and tell it to do the right tail, because that area, 0.115, was in the right tail. Lovely. Now, if you have an old calculator, then you don't have that option, which I have right here. So I have to do inverse norm, so second distribution inverse norm. But the problem is I can't use 0.115. If I do, it'll be on the wrong side. It'll be the left. So I have to do 1 minus 0.115. I have to do the complement, which is the blue one here, this area, plus the orange one here, this area. I add those two together, or in other words, I take the 0.115 away from 1, and I'll have what these two are. So I put those together. You can actually just type it 1 minus. It'll paste it in just fine. And there you have it.